Now you notice this angle here, which it gives us using this formula, will always give us the acute or the obtuse angle between the two vectors. Okay? So for example, I have two vectors here. I have two vectors. Let's call that one A and that one B. Okay? This formula would give me one of these angles, because you're happy there's really two angles which happen between these two vectors. There's like one in there, the acute angle, but there's also a reflex angle which happens around there. Okay? This formula will always give me the smaller of the angles. So it'll always give me that angle in there, in this case. If I move this, so let's say move it around here, okay? Again, there's two angles. There's this angle here, and there's this angle here. This formula will always give me that one, rather than that one, okay? So that's something to be aware of. Now, another thing to be aware of is actually, I'm able to get quite a lot from the dot product. Because have a look at my formula. Would you be happy that thing there is always positive? That thing there is always positive. Like the denominator is always going to be positive because that's a length, times them together, they're still positive. Yeah? So the denominator is always going to be positive. So what it's really saying here is that cos theta depends on, so let's say is proportional to, the sine of A dot B. Okay? It depends on the sine of A dot B. So what I'm interested in is, if A dot B is positive, what type of angle will I get? And if A dot B is negative, what type of angle do I get? So when I do my dot product, look at the sine, and it should tell me quite a lot of information about what type of angle I'm looking at. So am I looking at a situation like this, where two vectors are facing in roughly opposite directions? Or am I actually looking at a situation like this, where two vectors are quite close together? So in order to understand this, if I make a bit of space, I need to remember what my cos graph looks like. So can anybody remember, what does the cos graph look like?
It's from 1, it comes from 1, and then looks like
Yeah. Good, so it kind of comes down and it loops around like this. Now actually in this case, so that's 1, that's -1, that's 0, that is 90 degrees, that's 180 degrees, and then so on. And actually in this case, I'm not interested in any angles bigger than 180 degrees. Like I've said that. I've said that if I have a situation looking like this, this formula will always give me this angle in here. It will always give me the closest angle. It won't give me the angle around here. It won't give me angles over here. So actually, I can ignore anything that happens over here. Okay? I can ignore anything that happens over here. So would you be happy? I have two situations here. I have a positive region, so an angle above the x-axis, sorry, a region above the x-axis, positive. Okay? And I also have a negative region, a region down here. So let's have a look. Okay? Angles which are smaller than 90 should always be positive. Are you happy with that? So angles smaller than 90, in other words, acute angles, should correspond to a positive value of cos theta. Okay? Whereas if I look down here, these are obtuse angles, so angles between 90 and 180, and that should correspond to a negative value of cos theta. So let's have a look at this in terms of this. I've said that cos theta, in other words, the cosine of the angle between the two vectors, can be approximated simply by A dot B, by the sine of A dot B, because that's always going to be positive, it's not going to change anything. Like positive divided by positive is always going to be positive, a negative divided by positive is always going to be negative. So it depends exclusively on what A dot B is doing. It depends exclusively on what's happening here. So would you be happy then if A dot B is positive, so when I take the dot products on my two vectors, if that comes out as positive, because that's approximated by cosine of theta, okay, if this is positive here, so this is positive, that should correspond to an acute angle. Do you see that? Because if you have a look, that's a positive region on my graph, and that corresponds to an angle between 0 and 90 degrees. Is that okay? Yeah? So in other words, if A dot B comes out as positive, then the angle between my two vectors must be like that. They must be acute. They must be facing in roughly the same direction. Okay? So therefore, the angle between my two vectors is acute. And I can tell that from the graph, because a positive region on my graph corresponds to angles between 0 and 90 degrees. Whereas, if A dot B, so the dot product of my two vectors comes out as negative, then that should correspond to an obtuse angle. Okay? So therefore, theta is obtuse. So for example, if I just take two vectors like this, if I take A is, let's say, 3, negative 5, and let's say that B is equal to 1 and 7, okay, what is A dot B in this case? So it's going to be 3 times 1, isn't it? Plus negative 5 times 7. Okay, so 3 times 1 is, and 5 times 7, so it should come out as negative 32. Ah, right, okay, A dot B is negative, so according to this, if A dot B comes out as negative, that should correspond to an obtuse angle. Okay, should it correspond to an obtuse angle? Because according to this, cosine of angles between 90 and 180 degrees should be negative. Is that okay? Yeah? Whereas if I give you two angles like two vectors like this, so let's say A is equal to 7, 4, and B is equal to 8, 3, then what would A dot B be equal to?
56.
Yeah, good. So 7 times 8 plus 4 times 3. So what's that?
68.
68. Now, I'm not interested in necessarily what the value is. All I'm interested in the sign. That is positive, right? And I've said, cosine of angles between 0 and 90 degrees are positive. So therefore, because A dot B is approximated by cosine of theta, then because that's positive, then this must be acute. The angle between the two vectors must be acute. So somebody asked me the other day, they said, well, what is the point of the dot product? So I kind of went away and thought about it. And I said, well, actually, the dot product is a really quick and easy way of telling me whether two vectors are facing in roughly the same direction. In other words, the two angles are, the angle between the two vectors are acute. Or are they facing in roughly the opposite direction? In other words, the angle between the two vectors is obtuse. It's from this, okay? It's from this. It's basically saying that the sine of this can determine the sine of this. And if you think about the signs of cosine of theta, it's positive for angles between 0 and 90 degrees, and it's negative for angles between 90 and 180 degrees.
But minus 32, it's before 0, yeah? And it's also negative.
Don't worry about the value of this. The value of this doesn't really tell me much. I'm interested in the sign.
Plus or minus,
Yeah, because A dot B is negative,
yeah.
and that's approximated by this. So because it's negative, I know it must be in a region in this graph here somewhere. Sorry, this part of the graph here. Okay. Whereas because that's positive, it must be looking at angles in between here and here. Is that okay? Yeah. So I mean, this is kind of an extra little thing. I don't just want to give you the dot product and then like not explain it in its full usefulness, because actually it's a really quick and easy way of calculating whether the vectors are facing in roughly opposite directions or facing in roughly the same direction. Okay? And it all comes from thinking about this graph here, the cosine theta graph.